Hi guys. In this video I just want to show you very quickly symmetry and what that has to do with functions. Okay, so if we take a couple of examples, it will, I think, become very clear. So in this example we have a parabola. Okay, that's what this shape is here, a parabola. Okay, and it's on its side. Right, this graph, this shape here, this is what we call symmetric about the x-axis. So here's the x-axis. You can see that if you use the x-axis as the line of symmetry, you can fold that shape onto itself and it matches perfectly, or it would do if my diagram wasn't so terrible. So this example exhibits symmetry about the x-axis. Okay. For example, and this is another good way of thinking about it, if you come down from the graph to meet the symmetry axis, and then you go the exact same distance the other side, you should meet the graph again. Okay, and that's true of any point on that graph. Okay, so this parabola exhibits symmetry about the x-axis. This parabola here exhibits the same symmetry but around the y-axis. Okay, so here's the y-axis here. So if you fold this graph onto itself across the y-axis, it fits perfectly. Okay, and also every point on this graph will meet itself if you go the same distance to the line of symmetry as beyond the line of symmetry. Okay. Then this example here is not x or y symmetric, but it's symmetric through the origin. So the origin is this point here, usually denoted with a little o. Okay, the origin is the point 0, 0 in the plane. It's where the x and the y axis meet each other. Okay, that point there. So this graph is symmetric through the origin. Okay, and one way to see that is if you take any point you like on this graph and walk it across to the origin and then go the same distance the other side of the origin, you'll meet its image point on the other side. Okay, good. There's one other symmetry that we need to think about. Okay, or is interesting to think about. It's this one, right? Let's pretend that we don't have the bottom half of this graph just yet. Okay, here's our function. Okay, this is our function here in black. Okay, it has this kind of U shape. Here is the line y equals x. Okay, this plane runs exactly diagonal like this. It's the line y equals to x. At every point on this line, if you go up from the x, it meets the same value on the y axis. Okay, this line is important, as we'll see in a moment. Okay, so if our function f of x, if it takes some value, let's call it x, no, let's call it a just to be different. Okay, and it outputs a value b. Okay, so our function, what we're saying is that it takes input a and has output b. Okay, that means that is the pair ab. Okay, the pair ab satisfies this function here. When you put in a, it spits out b. Okay, well, think about what the inverse function would do. This inverse function, this little -1 here as a superscript just means inverse. Okay, and the idea of an inverse is very simple. The inverse of anything is the opposite in some sense. Okay, so what the inverse function does is when you put in b, it gives you a. Okay, so the function f here takes a to b, the inverse goes backwards, it takes b to a. Okay, so the point, not ab, but the point ba satisfies the inverse. So when you put B as the input into the inverse, it spits back A. You see? So it's working in a backwards direction. Okay. Well, if you look at this graphically, okay, if you look at this on a graph, this line y equals to x is special because when you cross this line, when you do it in a symmetric fashion, when you do it in its mirror image across this line, what this serves to do is swap the x and the y. So look at this for a moment. Here's my graph f of x. Here's my line y equals x. If I find the image of this function here through the line y equals to x, I get this. So you would get this by taking any point on the function, moving it to the line of symmetry and moving it the same distance across and building up that mirror image. Okay? These two graphs, these two functions here are the mirror image of each other through this line of symmetry here. Okay? And what that has the effect of doing graphically here is that if you have the point 1, 2 here, the point 1, 2, which is on our original function, and you walk it over to the line, and then walk it the same distance the other side, okay, you get to the point 2, 1. So what's happened? The 1 and the 2 have switched places. Okay, and we said before that if AB is the original input and output, the inverse function should be the opposite. It should be BA, and that's exactly what happens here. So the lesson from this is that the inverse function is the image of the original function through the line y equals to x. Okay, now this works for any function you like. You can take any function that you like and find its image through the line y equal to x, and you have its inverse. Okay, so you can see that symmetry can play a large part in areas you may not have thought it would appear.